You're listening to A Climate Change. This is Matt Matern, your host, and I've got a great guest coming on the program today, Karthik Velayutham. He is the founder and CTO of Katrick Technologies, and Katrick Technologies is based in Scotland, and they have developed wind turbines that oscillate. They don't rotate. So pretty fascinating new technology, has a lot of applications, can be put in places where kind of windmills can't be located these days. And so it has minimal impact on environment and wildlife, can be put in cities as well as rural locations. So has a lot of applications out there. So very exciting technologies. Glad to have you on the program, Karthik.
Thanks, Matt. Thanks for the invite. I'm quite keen to come and talk about our technology, and then thank you.
So a little bit about your background and how you came to the environmental movement and came to this particular technology.
So it's all started in 2016. I was working in some vibration conversion technologies, and I was called in by the finance and the transport ministers of Scotland. They did had a problem of bringing wind turbines into airports and highways, and because I was working some unique things, I was like, could you have a look into this side of the bringing wind into these environments, and then come up with their idea, and that's how it's all started.
Okay, and what is your kind of background from an engineering standpoint? How did you get into engineering?
My background is a bit funny. So I started my career as marine engineer. My family told that you won't like it, but I wanted to sail in the ship. I did, and then I started sailing in the ship in oil tankers as engineer. What I didn't realize that these large ships will most of the time they won't even go enter a port because of their size. So we anchor probably many miles away from the port, so you hardly see anything. So I didn't quite like it. So I would still stick to my marine side. So I came back and I wanted to do something related to that, and I'm quite good in design things. So I started doing naval architecture at Satellite University in Glasgow. And then from that, I got involved with some wave energy technologies, and then I did masters in offshore renewables, and that's how I came into the green technology side.
Okay. And how long has Katrick Technologies been in business?
I'm doing the project since 2012, since my university times, and then officially Katrick started in 2016. Okay. So, and for the first few years, it was only two of us, and we were doing we were getting some grants and then doing some research work with the universities. And only in 2020, we decided okay, we have done enough groundwork and we need to develop the company. We brought in lots of business-minded people on board, and from that, the company kickstarted.
Okay, so tell us a little bit about the wind turbines, and describing for the radio audience. Some of our audience is also going to be watching and seeing, so they can see it visually. But for those who can't, tell us a little bit about how these wind turbines oscillate and don't rotate.
So when this thing first came to me, bring wind energy systems into airports and highways and so on. One of the first thing I did is what is the problem statement? So if you want to bring something new, you need to make sure that you write the problem statement clearly, and only when the problem statement is correct, then only you can develop something. So then I started to look what's the problem here? So conventional wind turbines work perfectly well, but they work in a different environment. Higher above the ground, where there is no obstruction, the wind is predominantly laminar. So there's no turbulence. So what that means is you could easily capture those laminar flow and concentrate into one single shaft. And that's how pretty much all the rotary system works. In the ground level, the wind characteristics are very different. So they are turbulent. So turbulence means it has, as you walk in the streets or when you walk somewhere, you would see sudden gust. At some point you would see more wind, and some point you would see less wind, and this we call it turbulence intensity. So when you operate something which is rotating, where all the energy is focused into one single shaft, when you operate in an environment which is highly turbulent, you start to get lots of imbalance. That's the key difference between conventional turbine, why they don't work in the urban environments. The other one is if you have something which is spinning, it's NIMBY. Some people who like wind turbine doesn't want it in their backyard. So you need to create something which looks nice, which doesn't expose those blades spinning. And the other factor is you can't have very large turbines in the urban environment. It has to be small. So energy is like you could only capture the energy based on how much you are extracting. So if you have a small system, you can't extract too much energy. So we have something called the ducting effect. So combining everything, we come up with a design which includes a system which first channels the flow. So we bring the turbulence in small sections and we bring it into a more smoother flow. So that's why we use a duct. The duct also increase the aesthetics, so it looks much nicer. And then the ducting also increases the wind velocity, so the effective wind energy capture is enhanced through the ducting effect. The reason why we have an oscillating system is because we are working in such a small area. If we put something which is rotating, then it takes a lot of area. So the central hub will take a lot of area. So we are using oscillation. Also, oscillation, the reaction time is very, very faster than a rotary device because of the inertia and other things. So we did a lot of studies on the urban environment, the ground level wind, and came up with these are the challenges and these are the benefits, and then from that we come up with the design.
So tell us a little bit, just explaining the length of these ducts that are on your units. How many feet or meters are they long?
So the current system that we are developing is for the industries, and they are about 2 meters long and about 2 meters wide, 2 meters tall. It looks like a hex which has 6 ducts inside, and each duct has 2 aerofoils. And the reason why we have 2 aerofoils is effective energy capture. Because we are oscillating, we would never spin that speed of a rotary device. And then if you oscillate very fast, it creates vibration. So we actually go much slower than a rotary device. If you go slower, then you lose lots of energy. So we have 2 aerofoils, which increases the effective capture. So it's about like 2 by 2 meters, and the footprint is about 4.2 meters square.
Okay. And what's your current status as far as manufacturing these items? How are you proceeding as far as getting in these manufactured?
So we came up with a unique business model. So what we understood is a lot of new, very good technologies comes out from startup companies like ours, but then they fail, and the key reason for them to fail is they try to do the end-to-end process, everything by themselves. How good we are in generating new concepts and creating IPs that's our strength, but we don't have the knowledge on manufacturing, product development, because our team is small, the resources is very small. So our business strategy is to embrace multiple technology partners. So we develop the technology and we prove the functionality, we create a patent, and we license the patent to global OEMs who has the capacity to mass manufacture such things. And so we don't manufacture the technology. So we develop it and we license it to global OEMs who will manufacture it.
Okay. And in terms of licensees, are there any companies currently that are licensing your product in order to begin manufacturing them?
Yeah, we are currently in talks with one of global OEM. We are doing lots of sprint exercise with them because we are coming to the end of technology development, and then the product development needs to start simultaneously. So we are engaging with one global OEM. We are also talking with a couple of other global OEMs, but the one currently we are talking is actually quite advanced stage.
Oh, okay. Well, that's great. So you already produced prototypes of these wind turbines already, correct?
We have done prototypes to do lab experiments. We haven't done prototypes to do experiments on the real environment, and that's something the OEMs will do. So that's the conversation we are having. So they are preparing themselves to build the prototypes to go into the real environments.
And what is kind of the projection as to how many units they would produce in the next year or 2 years, 5 years, um, if they go ahead?
We are looking into the gap in the market. So we are going into Europe 16. So the top 16 countries in the Europe who are keen in renewable energy. So if you cover 1% of their onshore wind energy market, that's 1.7 gigawatts, which roughly equates to 1.7 million hex in the individual hex by 2030. Obviously, the potential for this global OEM is much larger than that. So we are working on it, like how we are going to manufacture, how long, what's the production line, and so on.
Well, it sounds like an amazing product. And we'll be back in just 1 minute to talk to Karthik about the amazing technology that he's developed at Katrick Technologies, and we'll talk to him further. So stay tuned. You're listening to A Climate Change. This is Matt Matern, and I've got Karthik Velayutham, who is the founder and chief technology officer of Katrick Technologies, which is a company that is designed wind turbines that oscillate. They don't rotate. So, Karthik, you were telling us about the model that you have in terms of how you're planning to license different companies to build these. Tell us some of the features that are related to them, as far as that it has minimal impact on environment, wildlife, captures more kinetic energy than conventional wind turbines, can be put in cities and rural locations, kind of be used as perimeter fencing for, say, like at airports or along the highways. And it also can be put in wind farms to actually double the output of the wind farms. That's pretty remarkable, because I guess there are dead zones between the different windmills where they're not actually capturing the air, closer to the ground, I assume, and your technology could be placed on the ground and capture that wind. Is that true?
Yeah. So one of the key advantage of entering into the ground level is wind turbines are quite large and they create lots of wake. So you need to have minimum distance. So on an average, about like 100 megawatt wind farm requires anywhere between 5 kilometer square to 30 kilometer square. So if you use like let's say if you use one turbine is 1 megawatt, only in this huge, vast area, you could only put 100 wind turbines. And there's a large amount of space in between them. So what you could do is we did some analysis for some local wind farms in Scotland. If you cover 1% of the wind farm area, you could actually increase 25% of the capacity factor of the wind farm.
Wow, that's a substantial increase.
And you don't have a huge visual impact because they are much closer to the ground rather than it's far away. And you could actually design these wind panels in such a way that it could blend in with the environment.
Now, that was just covering 1% of the ground space. I assume can you cover larger than 1% of the ground space and increase the efficiency rate or output of electricity even higher than that?
Yeah, you could. It all depends on some wind farms. You could cover 5%, 10%. It all depends like how many other factors are involved there. Some wind farms have a very open space on the ground level. Some has some tree, some fencing. Depending on wind farms, you could have much larger coverage.
Right.
There's no restriction. Yeah.
Right. So that could increase the level of electricity that's generated pretty substantially. I understand that the CEO of your company was invited to number 10 Downing Street recently to meet with governmental officials in an event for green tech startups. Maybe you could tell us a little bit about that.
Yeah, so we have won a couple of awards, and we were also featured in BBC Click program, which is to showcase our technology. And from that, he got invited to number 10. And basically, the reason for his invitation is how we are developing the technology and what the government can help us. So one of the key things we were asking them is solar is well understood. The power dynamics of solar, the wind turbines, they are also well understood. Ground level wind is something that nobody understands, because if you take the Met data, they only record data every 5 minutes or every 1 hour. They don't capture the turbulence intensities. So we are doing a novel methodology on the ground level to understand these changes. So that means when you start to generate power, there will be some discrepancies in the grid line. So you need the government support when you want to bring such an impactful technology into the market. So things like that, like we were discussing with the government, like what are the steps that they could take to help us bring this technology into the market as quick as possible, and for them, how could they use this technology to achieve their targets? Because if you take the current turbine technology, with the targets, there is 70% gap in the market, because there are only few companies who can manufacture these big turbines, and they don't have the production capacity to meet the targets.
So do you think that the current manufacturing base could gear up to manufacture your product as quickly to fill this gap and produce, whatever it is, millions of units that would be required?
Yeah. So the global OEM that currently we are in this talking with, they are also a key player in the wind turbine technology. But when they see this technology, they see this as mass manufacturing system. So for them, it's much easier to mass manufacture this, even though you need a large amount of this hex to compensate one single turbine, because they produce a huge amount of power. The capacity to mass manufacture is far more easier because of the components that we use here, and the installation is much more easier.
How many hexes of your product would it take to equal 1 megawatt turbine?
So each current industrial product that we are going to release as the first launch product is rated. It will be rated at 1 kilowatt. So you need 1,000 hexes to match one megawatt wind turbine.
Okay.
This is more to like a solar panels.
Okay. Well, I kind of got excited when I saw the technology. I thought you had on your website, it showed that you could put this up on homes and places like that to generate electricity, and obviously current technology it would be impossible to kind of have wind turbines on homes, but with your technologies, these hexagonal units, it seems like it would be possible to do that. And how many of those hexes would you need on a home to generate kind of self-sufficiency for the average home?
It depends on which location that we are talking about, because some places they use more power than the other. They use more electricity. So on an average, 5 to 6 in the UK, that would be sufficient for the home to cover. One of the key thing is we are targeting behind the meter element. So wind turbines are in front of the meter, so they supply directly to the national grid. Solar, you could use as a large solar farm to supply to the national grid, or you could use micro generation, which goes directly feed into the industries, to the to your homes, etc. But currently, the only option we have is solar panels. There's if you take the wind is more consistent throughout the day, and it blows more during the night and more during the winter time. So if you take one of the biggest electricity consumer in Europe is for heating, because we are shifting from gas heating towards electric heating, and this heating the building is taking more and more energy, plus charging your vehicles. So these are the two key factors that's going to play in the next coming years. And you normally require heating during the winter months and during the nighttime. You normally charge your car during the nighttime. So in both the cases, the sun doesn't shine that much, or it doesn't even shine, but the wind is quite predominantly high during these times. So that's why wind energy is very important to balance. So we are not trying to compete with solar, but we are trying to bring a balance in the load. So together, compensating solar, we could bring more balance in the load and enhancing renewable energy generation.
Right. And I guess if you have it at the micro level, then there's less need to build out a power grid, which I know here in the US, there's been a challenge of trying to build more power grid infrastructure to carry all the solar and wind energy that is being generated by the major wind and solar farms. Are you having similar problems in the UK?
Yeah, once you start going into like big wind farms or big solar farms, you have to start generating power at somewhere. We have used so much urban space, so we have so much built up area. Currently, the only technology which can go there and generate power is solar. Wind is quite high too in these areas. So if you start to include wind in those areas, then you have another technology which can generate another huge amount of power. So you could actually utilize the built up area that currently you use towards generating green energy. You don't need to go and destroy farms. You don't need to go destroy wildlife and so many things. You don't need to enter into those areas at all.
Well, that is a very big benefit from your technology, is because currently a lot of environmentalist groups are very concerned about the effect of these gargantuan solar arrays that do affect the environment at a ground level. And it seems though your technology would have a lighter impact on the environment and on wildlife than some of these massive solar farms. So, it's very promising. So you will be right back in just 1 minute. We're talking with Karthik, who is the CTO and founder of Katrick Technologies, which is a company that that has created wind turbines that oscillate. They don't rotate. So we'll be back in just 1 minute to talk to Karthik about this. Stay tuned. We can change the world if we do it You're listening to A Climate Change. This is Matt Matern, and I've got Karthik, who is the founder and CTO of Katrick Technologies, which creates a wind turbine technology. Karthik, maybe you can tell us a little bit about how you came up with the hexagon design.
So before we came up with the design, we first tried to understand what is the urban wind behavior is, and based on that we decided that okay, this is how the wind is behaving. These are the key things we need to do, and from that let's do a design. So what we learned from the urban wind is the wind fluctuates, the wind speed fluctuates every second, the wind direction change every second, the wind orientation change every second. So it's not a straight, smooth flow. It just constantly changes. And And if you try to extract energy from such a turbulent environment, the efficiency of the system will be very, very poor. So one of the first thing we need to do is we need to bring some kind of orderedness in the system. Like the system is the environment is extremely chaos. So we need to bring some order. So that's why we created, so we initially thought we need to create a duct to smooth the flow. Then it's to create a system which is actually visually looking, it should visually look good. And it has to also case the airfoils. So no one should see the airfoils moving. So people don't like when something is moving. So duct is a very important factor. The other thing is because it's such a small area that we are trying to capture, the energy density is very small. So we have to somehow capture this energy in a very effective way. So we are using a ducting effect, which is basically the area in the inlet is quite large, and the area in the midsection where the airfoil are placed is much smaller. So it just increased the velocity. So the energy capture is enhanced by that. And combining everything, we created the hex design. The oscillation inside came, if you have this hex design to smooth the flow, and if you put something which is rotary inside, the central hub will take a large area and it will create lots of turbulence. So we created an oscillation. And the oscillation also helps the system to react to the change in the environment very, very fast, very effectively, very fast. So our system is actually capable of changing to the environment almost every second.
So meaning they're kind of like oscillating. What's the material used on these? What would you call them? Oscillating arms or
airfoils?
Airfoils.
We use some foam material, but that's when we build prototype to demonstrate or to do some testing. The OEMs are looking into different material selections. They already started it. So they are selecting the materials based on recyclability, some of the environmental impacts that will have, and also the environment it will go and work on. So on the ground level, you'll have more dust and other factors. So they are taking everything into consideration, and they are working on it. The one big thing is our material selection is vast because we are oscillating and because we are such a small device. The effect of the load and other things is very limited. So we could our choice of material is quite big.
Oh, that's great, because obviously we want to use things that are recyclable, so we're not creating a bigger waste kind of footprint when building these.
We are also looking into recycled materials too. So we could.
Tell us about the wind studies that have been done and why those are important.
So typically, med data anywhere in the world, they use average wind speeds. So they collect the data, and probably I think the best is probably 5 minutes. Every 5 minutes they collect the data, or sometimes even 1 hour. Because the wind characteristics changes every second. You need to record this, you need to understand. The power is, as the velocity increase, the power exponentially increase. So a small change in the wind velocity gives you a huge impact in the power dynamics. If you are using the met data, because they are heavily averaging, you don't see that gusting effect or the turbulence intensity. So if you use the met data and if you try to work the power, and if you use our data, and the way we capture the data is high frequency sensors, which captures data every second. It can capture all the other factors of the wind, the direction, the orientation, and the speed. So if you use the met data and if you do the power calculation, and if you use our data and if you use the power calculation, it is actually it will come 3 times larger, because the met data is heavily averaged. And that's the reason why we are doing a novel wind studies with some of the universities in Scotland, and we are using the sensor in multiple locations. We are also doing CFD analysis, mainly for the airports. So how the building works, how the building influences the wind characteristics, where to install the system, where not to install the systems.
When you're referring to the med data, what is that referring to?
It's just I think different countries have different agencies who weather stations.
Okay.
So they measure the wind speed. The reason for that is there is before there was no requirement for such high frequency data because nobody was entering into this area of energy capture. For them, like average wind speed is enough for them to predict some climate or weather or something.
Right. Well, that makes sense. What is the wind speed that it takes to power your units as opposed to the wind speed that it takes to power a major, say, 1 megawatt wind turbine?
So we call it a cut-in and cut-out speed. So a very large wind turbine, they could cut in at like as low as 2-3 meters per second. From our studies, we want to do, our system can cut in at even lower wind speed, but we are developing the system to have a cut-in wind speed of 4 meters per second. Yes, it is quite high, so you will lose a lot of energy below 4 meters per second. The reason why we are keeping at 4 meters per second is our system is very small. The available energy below 4 meters per second is too tiny to commercially extract for such a small device. So that's why we kept it at 4 meters per second. Due to gusting, the average wind speed will be around 6, 7, 8, 9 meters per second. That's where you extract most amount of the energy. And our system can extract energy up to 18 meters per second.
And how fast is that in terms of like kilometers per hour or miles per hour?
Probably about like 15, 16 kilometers per hour cut in, and then probably cut out probably about like 80 kilometers per hour. We don't use kilometers per hour, so I'm just like, yeah.
Off the top of your head, right?
Yeah.
So in terms of turbines and solar panels, what is the benefit of your product over these turbines or solar panels?
So wind turbines play a key role in green energy, and they play a key role in a certain specific areas. And because our targets are like we need to be 100% green by 2030, by 2050, and so on, the targets are quite strict, and we understand that we need to go towards the green is probably one of the most important factors for the world. There's also limitations from these technologies, whether it's wind or solar. So for wind turbines, it can only operate in certain environments, and we are actually filling up these environments quite rapidly. Solar is more stable because we understand the way the sun shines. It's only the cloud factor which affects, but we do understand it very good now after 30 years of data collection. But the sun only shines during the day. And in the northern hemisphere, during the winter time, the sun doesn't shine that often. So there is a gap here. So we got lots of built-up areas which we are not utilizing for power generation. We already used the natural resources to create these large cities, farms, and other things where we used these areas. The only option we have is to put solar panels, and solar panels even though they are very good, they have some limitation. So there is a huge gap here. So in order to fill this is where these urban wind technologies will come and play a key role by extracting micro power generation in areas where wind turbines cannot penetrate or areas where solar cannot generate.
So does your hex unit actually rotate to get the when the wind changes direction, can your unit take advantage of that changing wind direction?
It's an external feature. So we have done some wind studies in the UK, and we have also looked into some of the wind characteristics in Europe. So in most of the countries in the Europe, the wind predominantly blows within a narrow region. The prevalent wind, the high wind speed, comes in a very narrow region, which is probably about 60 degrees. And time to time it flips completely in the opposite direction. So the way we created the duct is it can work effectively in 60 degrees. It can take the wind either coming in one direction or from the opposite direction. So it can do both. There are areas where the wind is even more turbulent, so it can go 360 degrees in some of the areas. And in those areas, you could have a pivot change where it could change according to the change in the wind direction. But that's an external feature, and that will add some cost to that.
Well, you're listening to A Climate Change. This is Matt Matern, and I've got Karthik Velayutham. Sorry, I am butchering your last name. Karthik is the founder and CTO of Katrick Technologies, and we'll be right back with Karthik in just 1 minute. We can change the world if we do it You're listening to A Climate Change, and I've got Karthik, who is the founder and CTO of Katrick Technologies. Karthik, I want to ask you about the patented technologies that you've created for these wind turbines that oscillate and don't rotate. Tell us a little bit about what patents you've obtained, and are you still working on further patent protection?
We got a couple of patents for the wind technology. The patents that we apply, because they are quite novel, so what we do is we don't apply the patent based on a product, we apply the patent based on a concept. So that means a number of different products can come out from these concepts. And we are able to do that because we are bringing unique ideas into the technology world. So what we have covered is a functionality of the system, the concept of how to extract energy from the turbulent wind condition. That itself could generate so many different product line that could address different market segment. And we also got a patent to capture the turbulent in a different powertrain. So we could use a number of different powertrains, whether it's mechanical, hydraulics, or pneumatics, and so many different options we could use. And there are so many different product lines we could get out from it.
Well, let's brainstorm on that a little bit. It sounds like you already have, but how do you envision this going in different directions in terms of using those different technologies you just discussed?
If you take, let's say, a car, there are different types of car. There are like SUVs, there are 4x4, there are hatchback, there are saloon. They're all meant to serve different purpose. They might have different engine, they might have a different powertrain, they might have a different gear system, controls, so body shape and so on. So similar to that, this urban wind technology will have different different product lines which will address different markets. So for wind farms, you would have much larger system which work in a different powertrain to address those market. For the industries, they have their own scope, and so they have a different powertrains and different shape, and they would address those industries. For residential, they are much smaller system which needs to go on the roof, plug and play, very similar to solar. So they will have a different powertrains and different design features.
Oh, okay.
So everything you could segment, and because we are protected fully, so the OEMs or the manufacturers, they don't need to worry for the next 20 years. So they could keep on release multiple product lines and keep covering more and more end users.
Well, I guess I would push back a little bit here because I'm a lawyer and that's what we do. I'll ask, there has been wind technology around for 500 years or more, capturing the wind. What if somebody comes and says, well, Karthik, yeah, that's an interesting idea, but there's been wind turbines and things like this for hundreds of years. Why can't we kind of do the same thing you're doing? How do you patent an idea like that?
It's because, yes, the windmills are there for like, I don't know, maybe 1,000 years or more than that. That's converting the kinetic energy from the wind into a rotary motion. We didn't patent that. We patent a particular concept which is suitable to work in the urban environment. So the patent covers what is the problem statement and how we are tackling that problem statement. And because that hasn't been, first, the urban wind hasn't been understood clearly. And second, because we understood this and because these are the factors or these are the designs that needs to be there, so we could actually cover the concept level. So we don't need to stick with this hex. We can have different design. We can have different number of airfoils. So there are so many features that we can add in or take off to suit a particular market. And that's how we protect the patent.
Do you see any other competitors kind of jumping into this area to use competing technology, or is this kind of virgin territory?
There are a lot of urban wind technologies. To be honest, there are lots of people tried on this. The one clear advantage we have is the understanding of the environment where we meant to work. I think that's where we differentiate ourselves. So there are lots of rotary systems to work in the urban environment, and as I said before, rotaries doesn't work because of the environmental conditions, and there are also lots of other oscillating devices too. But where we have achieved the success is by understanding, and then through the understanding, we have developed a design particularly suited for that environment.
Now, are there any oscillating systems that have hit the market already?
No, there are like some trials out there, very different to way we are doing. Some of them are open systems which oscillates in open air, but nothing particular close enough to us. And we also got the patent granted in a number of countries. So it's also coming into it's also filed in the US. So probably very soon we'll get that into a grant status. We did, so from the international search report, we didn't get too much challenge back.
Okay. So you patented in the EU already?
Yeah, so we patent in particular in areas where it is, we protect the technologies in area where it will be well useful as an end user, and also the areas where it will be manufactured. So we have covered those areas. Okay.
Yeah, I was curious as to whether or not you've patented in China and whether it's protected there, since that's obviously an enormous market.
Yeah, we have. Yeah.
Okay.
So they are all on our key markets. Yeah.
Okay. And as well as India, or have you?
Yeah, India. Yeah, we have even filed in Saudi Arabia because we were called in for one of the meetings in Saudi Arabia, but it was organized by their finance minister about bringing renewable technology. They are quite keen to manufacture it and to supply in the Middle East. There are lots of areas to address there because they have vast amount of pipelines, especially in the Iraq, Saudi Arabia, and so on. They are all remote locations. So for some reason, solar is okay, but because of these few heat and other things, they don't. They want something to balance. So this wind technology for them is very useful.
Okay, that's interesting. Well, I was just back at the COP28 conference in Dubai, and those countries in the Gulf are investing a lot of money, billions and billions of dollars, into clean, green technology, and maybe in part because they see the wave of the future, both financially, it's going in that direction, as well as they are experiencing some of the worst effects of climate change on the ground in those countries, and it's on the edge of unlivable at the temperatures that it hits in the summertime.
Yeah, and also a lot of people that we never thought would be interested, like banks, for instance. for the airports. So they are seeing not as a green technology, they are seeing as a marketing piece. So they could fund their airport, but they could actually put their ad or their logo on all these HICs. They do this for a lot of airports, so they think like, okay, this is actually a very good marketing piece, so we could actually fund. So it's a win-win situation for the airports, for the bank, for us. So there's also an interesting spin. We didn't thought about that. So there are so many different people are coming to us and talking about like how to utilize this technology and how to benefit.
Well, that's, I think, one of the ways that this whole environmental problem will be solved is harnessing capitalism with technology like the ones that you've created to for the profit motive. I mean, unfortunately, that's the way of the world, is that, business operates on having to make money, and we've got to create ways where green companies are going to make lots of money, and that will incentivize investors to invest. Speaking of which, are you all looking for investors at this point in time, and how much money do you need to raise to kind of take your company to the next level?
We are currently doing some investment round. We are talking to some large investment wings. Currently, we are looking for 3 million investment to take it to the next stage. We are also open for some smaller investment. So in the UK, we do EAS, so they got some tax benefit. But there are lots of people from America who came and invest in the technology already, and there are lots of people currently we are talking to. So we are open for any.
What's the minimal investment that you are open to at this time?
Probably in dollars, about like $5,000, because the amount of work we need, because it's coming from America, there will be some work, KYC and other works. So it will be better. We are a short team, so it will be easier for us to take anything over $5,000 as an investment.
Sure. So, we're close to the end, of the program. But Karthik, it was a pleasure having you on the program, and everybody should check out Katrick Technologies. That's Katrick Technologies. Great technology company in Scotland, and Karthik is founder and CTO of the company, and I look forward to great things from the company in years to come. And everybody tune in to us at aclimatechange.com, and you can follow us on Spotify or Apple or iHeart to listen to old shows on that. So everybody have a great week, and tune in next week. We can change the world.